The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, welcome to the second session of our Bloomberg Initiative for Global Road Safety and IndiaRAP webinar series, World Bank and iRAP helping save lives in Indian roads. Thanks for joining us today. For this webinar series, our topic today is a Star Rating and Safer Roads Investment Plan. My name is Alessandra Fransoy. I am the Training and Accreditation Coordinator at iRAP. I'll be your moderator today. And just a few very important notes for you. Our webinar has between 70 and 90 minutes, including time for questions. All attendees are muted during the sessions. For those that have entered the session using a phone call, please make sure you enter audio PIN, the audio PIN you received, in order to be identified by the system. You can only hear us and won't be able to see the presentation. If you enter this session through the internet, you can see the chat field on your control panel. You are welcome to post your questions on our chat at any time during the presentation. Our presenters will make a few stops and I will read your questions to them. They will answer for us. And this course has another platform with more materials for you. If you haven't registered on Schoology yet, please do make your student account on www.schoology.com and click join a course and use this access code that you see on the screen to enter the course. You should have received this information already in your registration forms. And this session is being recorded. The video and the presentation files will be available to you tomorrow on Schoology. So we have three presenters on this session. Dr. Saba May, the program manager at IndiaRAP. Hi, SG. How are you today?
How are you? Good morning. I'm fine.
Thank you for presenting today.
Thank you.
And we have Albin Tarakan, the road safety engineer at iRAP. Hi, Albin.
Hi, Ali, and welcome everyone to the webinar.
Thank you for being here today as well, Albin. Albin also is part of the IndiaRAP team with SG and Jigesh, and he helps with all the training, on-site training. So thank you for being here today, Albin. And we have Jigesh Bravazar, the technical manager at IndiaRAP and the senior road safety engineer at iRAP. Hi, Jigesh. I will introduce you and hand over to you to start the presentation. Thank you.
Thank you, Ali. Hello, everyone. Welcome back to the second topic of this assignment. And I hope this course is being very helpful. And the previous topic was very interesting for you. So let me start with the assignment. So we have some feedback from the previous assignment that we have. And we are really excited to see all the participants on the Schoology have submitted and in fact passed the test. So very well done, team. Now there were a couple of questions where some people either couldn't answer or had a bit of confusion how to answer. So the question on Bloomberg Philanthropies and GRSF report, the high toll of traffic injuries, reducing road traffic injuries by 50%. So that was the blank and the answer was to be given there. So if we reduce it by 50%, it would translate into an additional 7% to 22% of GDP per capita income growth over next 24 years. So in a question like this, when we have the blank, there we just have to type 50, not the percentage symbol, because it was already there in the question. Because these questions are being checked by the system automatically. If you type 50 and then percentage symbol, it will get wrong. So please make sure that you read it correct and fill the blanks in that way. The another question was select the correct statement with respect to United Nations Global Road Safety Targets. So the answer is there are 12 such targets. So the United Nations Global Road Safety Targets includes various targets, also 12 targets, and target number 3 and 4, if you remember, Luke Rogers, he mentioned about target number 3 and 4, which talks about the infrastructure safety, but other targets, they talk about road safety education or enforcement or the legal provisions, etc. So that was the feedback about the assignment. Now we had session 1 on the Tuesday, and today we have session 2, star ratings and safer road investment plan. So today we'll concentrate more on the plan and process. The next session on the So before I go there, just let me summarize previous session. So on Tuesday, World Bank team talked about the Bloomberg Philanthropies Initiative of the Global Road Safety, BIGRS, and World Bank's perspective on road safety. Later, my colleague Luke Rogers from iRAP talked about the background and United Nations Global Road Safety Targets. And at the end, I presented about some case studies and examples of iRAP assessments conducted in India. Now in today's session, second session, we are going to focus on the process, how the star ratings and investment plans are generated. In the third session on next Tuesday, I and Elvin will take you to VIDA, the iRAP online software, where the data is processed and results are stored. We will show you how to access results and use them for implementation. So this session will be helpful for the road authorities to make optimum use of the available results. The last session on this series on 11 June will focus on the overall process, how the road authorities can conduct safety assessments. Information will be provided on topics such as how to procure iRAP services, who can deliver high quality iRAP projects, and so on. The consultants and road safety engineers will get more information on how to be an iRAP accredited supplier so that you can participate in such projects. So that was an overview about this webinar series. Now, today we are going to have a brief introduction and background of the IndiaRAP, the local program, from our program manager, Dr. Gangopadhyay. Then I'll take you to the process, how the star ratings are generated, what are the data that requires to be collected, how these data are collected, and how these are used for implementation. And later, my colleague Alvin will take you to the star rating demonstrator, where he will show you how to do star rating of any particular road section or road segment with the help of just an image or photograph of the road and some supporting data. So that was the overview of today, and now I will like to hand over to Dr. Gangopadhyay.
Very good morning, dear participants, fellow panelists, and my colleagues. I will give you a brief overview on IndiaRAP today. The local program of road safety assessment in India is a result of collaboration between iRAP and Asian Institute of Transport Development, which is a non-profit organization based in Delhi. Though the presence of iRAP in India is since 2010, the local program was officially launched in November 2017 in the World Roads Meet held in Noida, India. AITD hosts the program. That being said, we have office within the premises of AITD, and IndiaRAP team works with AITD on several road safety aspects. We are very much thankful to FedEx for their generous support, which powers the day-to-day functioning of our team. As you are aware, one of the Sustainable Development Goals, SDG 3.6, says by 2020 we should have the deaths and injuries to half. The UN member states have agreed on 12 new global road safety performance targets to make this possible. Targets 3 and 4 in particular mentions about the desired performance levels for all new and existing roads. And the IndiaRAP is committed to provide technical support to the Government of India in its mission to achieve these targets. IndiaRAP team is involved in training and capacity building, such as training of road safety engineers under Ministry of Road Transport Highways Capacity Building Program led by AITD. Training a team of research scholars of IIT Kharagpur who prepared star rating and safer roads investment plan for 1400 kilometers of road network in the state of West Bengal. Participating in delivery of road safety audit training conducted by Central Road Research Institute and Indian Academy of Highway Engineers. As a part of BIGRS for Mumbai, over 150 municipal corporation engineers and planners of Greater Mumbai have been trained to use star rating as a systematic tool for road safety assessment. Accreditation training has been delivered to 2 firms in India to build local capacity among the professionals to deliver the iRAP projects. IndiaRAP team member is a part of the IRC's Technical Committee on Road Safety, and IRC is a body under the Ministry of Road Transport and Highway. We regularly interact with the Ministry of Road Transport and Highway, including National Highway Authority of India, and recently had a meeting with the Supreme Court Committee on Road Safety, which is the apex body set up on road safety in India. The IndiaRAP team has delivered numerous projects in India, covering about 18,000 kilometer road network, as we have seen in the session 1 of this webinar. Building the local capacity to conduct safety assessments and providing training and implementation support to the road authorities is the focus of IndiaRAP. Training and capacity building in the region to make systematic safety assessment to be more sustainable, and IndiaRAP team has provided such support in Bangladesh and is willing to train more professionals in neighboring countries, including Bangladesh, Nepal, Sri Lanka, which will help to build capacity among road authorities, and safety assessments can be conducted in a cost-effective manner. Safety assessments have been conducted in a number of states and also on national highways. Now, therefore, it is the time to scale up, learning from the past experience. Now, regarding technical support to MORTH and NHEI to conduct large-scale safety assessment, the team is committed to provide technical support to the government road authorities to conduct large-scale safety assessments to make the roads safer and save lives. For the support to include star rating as a target under road safety policy, many countries have successfully implemented the action plan as part of their road safety policy, which includes X percentage of road should achieve 3-star or better by a particular year in future. It is therefore time for India to have similar target in the road safety policy, and IndiaRAP team is here to support and help to develop such policy target. And with this, I conclude my presentation. Thank you all for your attention. We'll be very happy to take up any questions. Thank you.
Thanks, Dr. Sabame. We don't have any questions yet. We will stop again for questions. And actually, we received one now.
Okay.
What is the schedule to train Bangladesh staff?
What is that?
What is the schedule to train Bangladesh staff?
So if I can answer this question, Ali. So last year there was a World Bank project in Bangladesh where we did assessment of about 260-kilometer road under the World Bank funding. And in fact, in that assessment, the local team of Accident Research Institute under the Bangladesh University of Engineering and Technology, BIGRS. So they were involved. So we trained the team, and with the help of the team, we did this assessment. In fact, the team went to the site and collected all data as per iRAP specification. That we are going to see more details in my next session. But the team was trained, and now they are capable of performing such local assessments. So as Dr. Gangopadhyay mentioned, we are committed to deliver such more training in Bangladesh, Nepal, and Sri Lanka. That means we are ready to train. So if anyone from the audience or from the local government, they want to get more training, you can please get back to in touch with the World Bank team there, or maybe directly with iRAP. So that's what I suggest.
Okay, we have a few people asking for training in Sri Lanka. So this is the answer. Okay, thank you. So we have another one. Has IndiaRAP use video analytics in the road safety assessment?
Sorry, Ali, please come again. Video analysis or video?
Yeah, video analytics.
So in my next session, I will show more details on what data is collected, and that's the process we have used in India, and how the video data is used to generate the star rating. So that I think will be covered in my next session in more details.
Okay, so I think we can move on, and then we'll have another break for questions soon. Thanks, Jigesh and SD.
Thank you.
So now I'll talk more about the process, how the star ratings and safer road investment plans are generated, and they are used for implementation. So you can see this flow chart. It shows the process of generating star ratings and the safer road investment plan. We call it is SRIP, safer road investment plan, SRIP in short. So now onwards I'll talk SRIP instead of talking the full name. So the process starts with data collection that includes running a vehicle on the road to collect road images or video and GPS data. Now that data is brought to office and viewed by a team of trained professionals who extract the required road infrastructure attributes for every 100-meter segment of the road. Now this stage is called data coding. Now in addition to the data coding, we also need some supporting data like traffic volume, 85th percentile speed, etc., which are required to be collected separately, as these data cannot be collected by running a vehicle or videographic. Now this data together goes in the iRAP online software called VIDA, where the data is processed and the results are generated. So the software processes data and generates star rating for 4 road user groups, as we have seen. It also gives us the road condition report. For example, on the surveyed network, how much is the length of footpath, or how many intersections are there, and so on. The third part shown here is the SRIP, which gives a list of economically viable safety treatments, estimate of death and severe injuries that can be prevented if these treatments are implemented, and along with some economic analysis. Now in this stage, implementation, these results are often used by the planning authority, or let's say the road authority, who is the implementing authority, for preparing designs and preparing the investment plans. At that stage, we can also do star rating of design. So this is similar to doing road safety audit at the design stage. And in the previous session, I have shown some examples where we did star rating of design. When the design get implemented, after the construction is finished, we can do again same process, starting from here, doing the survey, coding, etc. So that is called post-construction assessment. So these post-construction star rating, it helps us to understand what has been built and whether it has been built as per the design or there are some deficiencies or more improvements are required. So this is the overall process. Now, before we go into more details in the process of data collection, how data is collected, I'd like you to explain how the star rating model works. So the model is based on the crash system, how the crashes happen. So here in this image, you can see there are 4 road user groups present. Vehicle occupant shown by symbol of car here. We have motorcyclist, we have bicyclist, we have pedestrians here, here, and here. Now there are different types of crashes possible in a situation like this. For example, a vehicle or motorcycle loses control and goes off the road, this side or this side. That's called a runoff crash. In fact, vehicle when goes off the road, it may hit the pedestrian as well. Now, vehicle or motorcycle carries out an overtaking maneuver, and during that, it may involve in a head-on collision with another vehicle coming from opposite direction. Vehicle or motorcycle taking turn at the intersection may involve in a collision that we call intersection collision. A pedestrian walking in the roadway, maybe here or here, hit by a vehicle, so that we call when pedestrian was walking along the road hit by a vehicle. Or pedestrian while trying to cross the road, for example this road here on the intersection or this main road, may be hit by vehicle, so that we call pedestrian crossing collision. Bicycle or motorcycle may be hit by another vehicle from rear or from the side, so that's the along type of crash for pedestrian, bicycle and motorcycle. So these are the major crash types which are covered in the star rating model, or the star rating model is based on these crash type, as these are the majority of crashes which happen in such a mixed traffic situation. Now a bit more deeper, if we see how the runoff crash happens. So runoff crash is the one when the vehicle or the driver loses control and the vehicle goes off the road this side or this side. So vehicle may go run off on either left hand side or right hand side. Now here in the iRAP terminology, we call it passenger side or driver side. So in India, we drive on the left side. So driver sits on the right hand side of the car. So this is called driver side. That means right hand side is called driver side and left hand side is called passenger side, as passenger sits here. So the vehicle may go run off on the passenger side or driver side. Now what happens when the vehicle goes away from the road? The driver may understand that he is losing control and he may be able to recover and come back. So in that case, the crash initializes but doesn't happen. On the other hand, if it goes run off on the driver side, and if there are enough vehicles in the opposite direction, that crash may result into a head-on collision. If low traffic volume, the chances of head-on collision are less, but it may go run off on this side. So these are the crash types which I mentioned. For vehicle occupants, we have the runoff collision on the driver and passenger side, and same way for motorcyclist. There are 2 types of head-on collision. So head-on collision happens because the driver loses control. Now that reason may be anything, maybe talking about phone or maybe some infrastructure deficiency. Or driver is trying to overtake. That is, he is completely aware of the situation. He is trying to overtake and involves in a head-on collision. Any crash happening in the intersection area, so that's the intersection crash. Crash also may happen with the vehicles entering on the road from adjoining properties, such as fuel stations or residential or other commercial buildings. For motorcyclists, we also have along type of crash where the motorcyclist is hit by any other vehicle from rear or from side. For pedestrian, it is either while walking along the road, so pedestrian may be walking on the footpath or on the road itself, and hit by vehicle, or crossing the main road or crossing the side road in case if there is intersection. For bicyclists, similar to the motorcycle, we have runoff crash, or we have intersection, or the along type of crash. So these are the major types which happen in such a situation, and the star rating model is based on this. Now the iRAP model calculates star rating score, that is called SRS, you can see here, and it is calculated based on the road infrastructure data, traffic volume and speed. So this is the basic structure how it is calculated. So you'll see that there are 4 components here. The first one is the likelihood of a crash. So if some road attributes are poor or bad, the likelihood of or probability of a particular crash type occurring is very high. If these attributes are good, then the probability is low or likelihood is low. Then comes severity. So if a crash happens, even if the likelihood is very low, the crash may happen. So if the crash happens, what is going to be the level of injury or the outcome? Now again, it depends upon some types of road infrastructure attributes. Then comes the external flow influence. So for example, high traffic volume, higher chances of crashes occurring. And this one, operating speed, is very obvious. High operating speed or high traffic speed, higher is the risk of crash. So these are the main 4 attributes how the star rating score is calculated. So the star rating score is a mathematical value. So when we get star rating score calculated, it is a mathematical value. And if this score is high, the risk is high. If this score value is less, risk is less. So the road segments with high star rating score, they get poor star rating because the risk of crash is more, like 1 or 2 star. The road segments which get low star rating score, they get better star rating, such as 3, 4 or 5 star rating, because the risk of crash is low. Okay, now I have a question for you. What are the road attributes that affect likelihood of a runoff crash? So think if these attributes are bad, the likelihood of a runoff crash or the probability of a runoff crash happening is high. Imagine if you are driving and think of road infrastructure attributes. Now to answer this question, you will have to go onto this website, menti.com. So you can open in your browser, you can also use your phone, open browser and type menti.com, or you can do it in your laptop, open browser and type menti.com, and there you'll see this type of box, and you will have to type this code 643508 and hit submit, and you will able to see the question. Okay, so we are looking at the results live. We are getting some answers. Yeah, come on, we have just 1 minute for that. We don't have much time. We have 4 answers yet. Yeah, it's increasing, good. Okay, so we are getting very good fast responses. So many of these road attributes you'll see here are the road infrastructure attributes like lane width, radius of curvature, etc. But there are also some other than road infrastructure attributes like driver talking on phone, or for example vehicle tire condition. So that relates with the vehicle condition of vehicle maintenance, etc. Okay, we have more than 100 responses now. Great. Okay, so I'm going back to the question now. So it's good to see many of the people have responded. For example, radius of curvature is one of the highest, getting more than, it's going to cross 100. So that's great. Lane width, road condition, road markings and signs, and so on. So that's really good that you are thinking that road attributes infrastructure is responsible mainly for the likelihood or governing the likelihood of the crashes. So these are the factors or the road attributes. Lane width, if the lane width is narrow, the chances of going off the road are more. Curvature, that is the horizontal curvature, very sharp curvature, high chances or high probability of going off. Quality of curvature, that is the quality of markings and signs to warn the driver in at the curvature. Delineation, that is road markings and signs. Shoulder rumble strips, so if we have rumble strips marked here on the edge line or on the shoulder, what happens when a driver goes off, he gets vibration, the vehicle vibrates, and the driver may regain the control and come back. Road condition, so if we have too many potholes or bad condition, you may try to drive zigzag, and that increases chances of going off. Vertical gradient and skid resistance. So if the road surface is very smooth or shiny or have some loose material on it, when we apply a brake, we often skid. The vehicle often skids, and that increases the chances of going off. In the question, you have seen there are some other factors mentioned which are not related to road infrastructure. As we have seen in the previous slide, now we are only concentrating on the road engineering infrastructure, and that's the point. The iRAP star rating model, it is based on the road infrastructure. Though for example, driver talking on phone, that may be one of the reason for run-off crash, no doubt. But by engineering, doing some engineering treatments, we can't answer that. So the safe system approach, which was mentioned by Krishnan yesterday, which says that we should build forgiving roadside. So even if a driver makes a mistake, the infrastructure should not punish the driver. So the infrastructure should be such a way that as far as possible, the level of injury is minimum, even though the driver is making mistake. And we are human, we are bound to make mistake, whatever we do. But the safe system approach also talks about how to reduce this, so educating drivers and better enforcement and all. So the star rating model is based on the road infrastructure attribute, concentrates on the engineering part. Okay, now next question: what are the road attributes that affect severity of the run-off crash? So if the crash happens, the run-off crash, what will be the level of outcome? Or what will be the severity, minor injury, major injury, or death? That is a fatal crash. So again, go back to your menti.com and you will see the update. So you will see the next question. So this is the next question. What are the road infrastructure attributes that affect severity of a run-off crash? So you already have opened that menti.com and you'll receive another question. You'll see this question now. Okay, so we have got responses. So think about level of injury. If the vehicle goes off, what will be the outcome? Whether it's going to be a minor injury or major injury. Yeah, we are seeing the maximum responses for this one, speed of vehicle. In a way, that is correct. But if you see the star rating score equation, speed of vehicle is a different factor. It's fourth one in this sequence. So now we are talking about severity, and we are only talking about the infrastructure attributes. Speed is anyway, it is very important, and speed comes everywhere, even in the likelihood or severity or any crash type. Speed is the most crucial part. So it's great. We have got 160 responses. Now I'll take you back to the presentation. So see, these are the attributes which affect severity. So roadside object, what type of object is present? For example, if there is a tree or pole, there will be some injury. If there is a cliff on the, if it's a hill road, and if there is a cliff, the vehicle is going to get into the cliff, and that may be a fatal crash. So the level of injury or severity, that depends upon what type of object is present. The next important thing is distance to object. So how far is the object from there? For example, if a tree is here, comparing a tree far away from the road edge. So when the vehicle hits any object, its speed gets reducing if the object is far away from the edge of the road, and that brings the clear zone concept into picture. We also have paved shoulder width. So normally this paved shoulder, there is no object on the paved shoulder. All solid objects are beyond paved shoulder, and it also acts as a buffer zone between a buffer zone, and gives a chance of recovery. So these are the three road infrastructure attribute which affect severity of the crash. Speed, as I mentioned, no doubt it's very important, but it's not one of the road infrastructure attributes. It is something like external flow influence factor. So now I'll show the example of risk factor. So what here we are seeing is a chart showing some data. So this chart shows a relation between crash rate and the curvature. So on the vertical axis, we have crash rate, number of casualty crashes per 100 million vehicle kilometer traveled. And on the horizontal axis, we have radius of curvature. So you'll see very sharp curvature here, 100 meter, 200 meter, and so on. And here it's very large radius, so more or less straight alignment. So you can see in the sharp curvature radius, the crash rate is high, and when radius increases, the crash rate is reducing. So this chart is prepared based on some actual crash research. Now the risk factor for very sharp curvature is 6 because it is nearly 60, the crash rate, and for straight curvature the crash rate is 1 because it is nearly 10, and the risk factor for sharp curvature is 3.5, and for moderate curvature is 2.2. So these 4 are the categories of horizontal curvatures in the iRAP star rating model, and these are the risk factor for each one of them. What this means, if we have a very sharp curvature, if we change it to straight alignment, or we compare it with another straight road alignment, the risk reduction is from 6 to 1. So that's the ratio of risk reduction. You may be aware of the terminology called CMF, crash modification factors. So crash modification factors are based on this type of risk factors, and which are based on the global road research on road safety. This is another example, risk factor for pedestrian crossing. Now imagine if you are crossing a road, the risk of being involved in a collision with vehicle is high when you have to cross more number of lanes. For crossing 1 lane in each direction, the risk factor is 1, and it increases to 8 when you have to cross 4 or more lanes in each direction. So that's very obvious. You have more exposure to the risk when you are crossing a wider road. Now, if you want to know more about these risk factors, we have more information is available, and for that you'll have to visit irap.org. So open the website, and not now, later when you want to see more details, go to the resources in this top menu and click on methodology, and you'll find a series of fact sheets. So you'll find some fact sheets on the iRAP methodology, which gives the background of the model, how the model is built, and more information. There are some fact sheets on the road attribute risk factors, like the 2 we have seen in the previous slide. All of the road attributes that we captured during the data collection process, there are some risk factors, and you'll find all information in this series of fact sheets. Now coming back to the process, the data collection, the first stage is road survey. So the road survey is conducted often by using a network survey vehicle, such as this shown here in this image. You can see it has got essential equipment like cameras mounted on top and a GPS receiver mounted here. So these two are the basic minimum requirement for collecting iRAP road survey data. Now this particular network survey vehicle has got some additional laser profilers and few more equipment which are optional for iRAP assessment. For iRAP assessment, the basic minimum requirement is to have the camera and GPS. It is also possible to do this kind of survey using a small camera, or we call it action camera like this. So this camera has got inbuilt GPS function, so you can record video images with GPS. And this camera is of the size of a business card. But what we say, this is only good up to a small road network length, maybe about 100 kilometers, because managing the data gets very difficult when you're using this type of data, this type of small camera. Whereas these kind of systems are built in, they also have special software for data coding, such as this shown here. So to extract the road attributes from video images, so once you run the vehicle, you collect video recording of the road and GPS data. It is brought to office, and some softwares like the one shown here with the network survey vehicle, they provide this kind of facility. So we saw 3 camera mounted on the top of vehicle, so you have 3 views here, and all 3 are synchronized. We also have a measurement grid here. So in here, if you want to measure lane width, just draw a line from here to here and it will tell you exact width. You can measure distance of any object from edge of the road. So draw a line and it will tell you it is 5 meters or 10 meters away from the road. So the special software that enables this kind of data coding, and that is really helpful, and it's essential if we are doing a large scale network assessment. On the other screen, the person who is entering data, he will have a rating form like this. So this is as per iRAP specification with drop-down menu. So the coder or the trained person, he or she will have look at the video images of that particular 100-meter segment, enter correct options here, save, and move to next 100-meter segment. So that is how the data coding happens. Now, to ensure top quality and uniformity in data coding process, iRAP has developed specifications and manuals, and I'll show more about those specifications and manuals in this session. So these are the road attribute data recorded. These are some of the key data recorded during the coding process. For example, in the image shown here, horizontal alignment, you can see it's a curvature. What are the roadside hazards present on the side of the road, like trees visible here? What is the type of median, lane width, number of lanes, condition of the road surface, delineation, that is lane markings and traffic signs, presence of paved shoulder, intersection, if any, what type of intersection, whether it is a 3-leg intersection or 4-leg intersection, whether do we have any traffic signal on the intersection or turning lane for vehicles, and so on. In urban area, often we'll find these kind of facilities for pedestrian, for example, footpath or a nice crossing like this, traffic signal, street light, and so on. So these are some of the road attributes, and in total there are 50 plus road attributes captured such as these during the data coding process. Now, to get more information on the specifications and manuals, you will have to again go to the resources and click on specification here, and you will find the iRAP survey manual, which helps us to provide the it provides the detailed information about road survey process and data collection specification, what data is required to be collected. The iRAP coding manual, it defines the 50 plus road attributes with examples and images. So that's a you can say it's a Bible for the people who are doing the data coding. The upload file specification provides specifications of the file containing the road attribute data, which is given as an input to the model. So at the end of the data coding process, we prepare an upload file that is like an Excel file or in a tabular style, and that goes in the VIDA software. The video data that we collect, it never goes in directly in VIDA for processing. sometimes people ask us how we use this video data into VIDA. So we use that video data for coding purpose, and that data coding goes in the software for further processing.
Jigesh, can I just ask a question that we have here about the survey? Do we need to always use a vehicle, or can we manually collect some data and images? For example, because of the cost and the rural roads?
Yeah, so what I suggest, if you are a rural road authority and if you have a small road network or very low volume road, you can use the small camera like the one I have shown, or maybe it is possible to even use your phone. The only requirement is to have a nice quality image covering both sides of the road, plus the GPS data. So every image should have a GPS reference or the latitude and longitude recorded with the image. Sometimes we have also seen that some of the students who are doing their thesis or the project, they use their mobile phone to capture images. And exactly that is what Alvin is going to show in the demonstrator. With the help of just one image, you can do star rating. So we have specifications, the road survey specifications, as I have shown. They never tell that you have to use this kind of network survey vehicle, a big vehicle. And there are a wide range of network survey vehicle or type of vehicles. Some of the vehicles are or the equipment are fitted in a small vehicle to do the asset management data collection with low cost. So it is possible to use the small camera like I have shown, or the full network survey vehicle, or any other system which is available. But please make sure that it should match the video resolution, the GPS accuracy should match with the iRAP specification.
Okay, thank you very much. You can continue. Thank you.
Okay, great. So now I will show you what are the supporting data required. So we need some economics data like GDP per capita income of the country or the region where we are doing the assessment. And I'll show later why we need this. We need traffic volume data, for example, AADT, the average annual daily traffic, the number of vehicles using that road in a 24 hours period. So that is required. Operating speed of vehicles, this is very important. So we need 85th percentile and mean operating speeds measured in different land use. So our road may have different type of land use or area type. Some part may be urban, some part may be rural with some development or with no development. And we need this kind of speed on sample basis measured in different land use types. We also need pedestrian and bicycle flow. The peak hour flow data is required. So in a peak hour during the day, how many pedestrians and bicycle use that road segment, how many pedestrians cross the road, and so on. We also need some road crash data, and I have one more slide on this road crash data showing with more details. We also need countermeasure cost. So there is a list of about 90 different countermeasures or the road safety treatments for rural and urban area, and we need typical construction cost, like what would be the cost of doing road markings for 1 kilometer of the road. So that in that way we need the typical construction cost for all these 90 treatments. So now when it comes to road crash data, it's very important, and that is required to generate the safer road investment plan. And the model is calibrated with the crash data. Now people often tend to think it's difficult to get good crash data in developing countries, which may be right. Now here for this analysis purpose, we don't need much detailed or accurate crash data. We need the data to tell us how many people died on the road network being assessed and its distribution, how many vehicle occupants died, how many motorcyclists died, how many pedestrians and how many bicyclists died on this road segment in the period of 1 year, last 1 year. We don't need location of crash. This data is often not available in developing countries. We just need total number of deaths occurred on the road network. without any location specific. So this is the restriction, or I'll say limitation in the developing countries, that we don't have very good crash data with the GPS coordinates or exact location. And the star rating model, or the model to prepare these safer road investment plan is being developed in such a way that it can be utilized in such conditions. Now, you may be aware that there is some economic cost associated with each death happening on the road due to road crash. Now that's the question here again. So you'll have to open again the menti.com and answer, what do you think, how much is the cost of a road death in India? So let me set up this and you'll see your next question here. So how much is the economic cost of a death in India? So our options are 15 lakh rupees or 1.5 million rupees, 55 lakh rupees or 1 crore, that is 10 million rupees, or 1.2 crore, 12 million rupees. So it is some approximate value. You have to guess, or if you know the correct answer. Yeah, interesting to see so many people are choosing the least value, 15 lakh rupees. Okay, so now I'll get back to the slide. So see here, most of the people are choosing the least value, but then about 40 is choosing 55 lakh rupees and about 34 1 crore rupees. Okay, so I'll get back to the slide here. So World Bank did a research covering many countries from different regions and continents. This research established that the economic cost of a death in low and middle income countries such as India is 70 times per capita income of that country. Now you see, the when a person dies in a road crash, that is a loss to the nation. Definitely it's a loss to his or her family, but it's also loss to the nation in terms of the lost GDP or per capita income. So that is associated with the GDP per capita, and it is 70 times that amount. The cost of serious injury is 1/4 of cost of death. Now, if we look at the per capita income of India from the recent published data, it is about 140,000 rupees, and the cost of death goes close to 1 crore rupees or $131,000. So that's the correct answer. It's about 1 crore rupees. Now, this is when we set up the project in VIDA, these are the inputs we have to give. So it's not necessary to always give this value. If you have more or the data which is published by the government or more data, this is customizable. You can input your own value. And the cost of serious injury is about 25 lakh rupees or about $32,000 US. So that's the cost of one death and serious injury. Now the Safer Road Investment Plan in session 1, Luke explained what SRIP provides. To summarize, it provides economically viable safety treatments, tentative construction cost, benefits, and how many deaths and injuries can be prevented. So preparing the SRIP, it involves calibration and localization of the model to ensure the investment plan matches with the local conditions, and the model is calibrated with known number of deaths that comes from supporting data that we collect. Now the investment plan reflects local conditions, practice, and experience with a range of local data such as road crash data, vehicle operating speed, traffic volume, motorcycle percentage, pedestrian and bicycle flow, value of life and serious injury, the construction cost, and some economic analysis data. So that is how each time the model is calibrated and prepared in such a way that it suits with the local condition. Now, how does the model estimates the number of deaths and injuries? So what happens in the existing road network when we do assessment, the model does distribution of the known number of deaths and injuries on this road network. So as an example, this chart shown here, it is called risk worm. Now on the vertical axis, we have star rating score. Remember, higher the star rating score, poor are the star rating. So you can see here, high score gets black color or 1 star, and low star rating score gets green or 5 star. On the horizontal axis, we have road distance or chain age in 100-meter interval. So this data is taken from a road assessed in Bangladesh, and you can see very low star rating score here that is on this road section on a bridge on the river where we don't have actually any intersection or curvature, and there are crash barrier on both sides of the road, so that is safer for vehicles, so we get low risk. On the other hand, we have this section where the star rating score is very high and it gets to 1 star. So here we have intersections, we have curvature, we have hazardous roadside objects present on both sides of the road. So now what happens when during the crash calibration stage, the model distributes known number of deaths and injuries, that is as per the record or data that we collect, and it distributes that data along the network or corridor according to the level of risk, that is the star rating score you are looking here, and the exposure, that is the traffic volume and VRU flows or the pedestrian flow. The road sections with high star rating score, obviously it will get more number of deaths, and such sections will get less number of deaths and injuries. Thus, the iRAP model distributes known number of deaths and injuries on the network or road corridor, and it doesn't predict number of crashes. Hence, it is not a crash prediction model, rather crash distribution model. This is also a question people sometimes ask, whether it predicts the number of crashes. So we always say it estimates the number of deaths and severe injuries. Now, the next question comes, how the model estimate reduction in FSI, that is the fatal and severe injury or number of deaths and injuries. So that is the part of the Safer Road Investment Plan. So in this illustration, we have the existing road and we have star rating score, which gives us star rating. The model is calibrated at the time of baseline of the existing road. Now let us say that the SRIP includes treatments like new facilities for pedestrian delineation and improved road condition. Now the software creates scenario for this improved road, and with the help of risk factors of each road attribute. For example, you can see here there is no crossing facility for pedestrian, and we are putting new crossing facilities for them. So the risk factor for no crossing facility is 6.7, and it is reduced to 4.8 for this marked pedestrian crossing, and so on for the road delineation. So with the help of this risk factor, the model again calculates the star rating score for this situation, the improved situation, that is the scenario. And now again, using the new SRS and exposure, it estimates the number of deaths and injuries, and these are likely to be lower than the existing number of deaths and injuries because we are improving the situation or reducing the risk. And the difference between this number of deaths and this estimated number of deaths is a saving. That is how we calculate saving, how many FSIs or how many deaths and injuries can be saved. Now, more information on these type of road safety treatments, their effectiveness, and with pictures and images are available on toolkit.irap.org. So this is the road safety toolkit developed by iRAP and the Global Transport Knowledge Partnership. So you can visit this website if you want to see more details and examples, images of different treatments. Now the SRIP also estimates the benefits, the economic, and as part of economic analysis. So estimation of benefit is quite simple. I'll explain this quickly. So we have the estimate how many deaths can be prevented, and we have its cost of a death. So multiply, you get the total amount, and same for severe injury. So that is the annual economic benefit. Now we do this analysis for a 20-year period or a different period for number of years, and for that we need to estimate the net present value of benefits. We have construction cost of all treatments because the SRIP provides a list of treatments, and we have construction costs. So we can, the SRIP also gives total construction cost. And ratio of these two is the benefit to cost ratio. So that is how we estimate the benefit cost ratio and other important parameters of the economic analysis. So this is how the Safer Road investment plan looks in the VIDA when we see results. That we will see more details in the next session. So these key headline numbers given here, these are for the economic analysis for a 20-year period. So it shows how many FSIs, that means fatality and severe injuries, can be saved in this 20-year period if all these treatments are implemented. That shows the present value of safety benefit in the local currency. That shows the estimated construction cost. That's a tentative cost. And this shows the amount required to be invested in order to save one death or severe injury. And the BCR is nothing but benefit divided by cost. So each rupee invested will result into the benefit of 2 rupees. So that was the process and the methodology about of the star rating and Safer Road investment plan. Now, thank you for listening, and I'm happy to answer any more questions if we have.
Yes, we have. We have a few people asking if the specifications talk about how to collect the speed data and flow data.
Yeah, so definitely the iRAP specification, for example, the road survey specification, that will tell you what data is required to be collected, and the sample period and the number of locations where it is to be collected. Now, for collecting the speed data, there are different ways. So there are equipments available like the radar gun or of different types. So the specification doesn't tell that you have to collect speed data using a particular equipment. It is up to you how you want to collect data. For example, for traffic volume, there are a number of ways how to collect that data. You can do manual count, or you can have a different type of equipment like loop installed in the road itself, or a video camera to collect traffic data. So iRAP specification won't tell you exact way how to collect or using which equipment to collect supporting data, but it gives overall guidance what data is required to be collected.
We have another, I will say another question because we are tight on our time, but it's an observation about the comment you made that the cost of accident, death, and serious injury is 70 times GDP. The person is saying that it's quite high for India.
Yeah, so definitely we always get this question whenever I present this in India. People think that the cost of death is just 10 lakh rupees or 15 lakh rupees. I don't know from where it comes, but people, I think we need to be more serious about the loss to the nation caused by the road fatalities. If we have any government published number, definitely we can use that in the analysis. It's not necessary to use this number. This is just a research I have shown done by the World Bank at global level, including countries like India. And that's just a suggestion. If we have any other published data, we can use it for this analysis.
Thank you, Jigesh. We'll have another break for questions, and I will hand over to Albin to start the demonstrator. Thanks, Jigesh.
Thank you.
Thank you, Ali. Good morning again to all. So now we'll see how we can do star rating for any road segment by having just an image and some data of the road using iRAP star rating demonstrator tool. Demonstrator tool is available in iRAP's online software VIDA at the web address www.vida.irap.org. You will need to register on VIDA if you haven't registered before. You can register using your name and email ID. After you log into VIDA, you will see the dashboard shown here. Select the demonstrator icon to open the tool. In demonstrator, we have all the road attributes needed for star rating listed as a coding form. So you can see the road attributes are required to get star rating are grouped under 6 different tabs. First, we have the roadside tab, under which we have attributes like type of object present on the roadside, distance to the object, presence of paved shoulders, etc. Then under mid-block tab, we have attributes such as what type of median is present, number of lanes, curvature, road surface condition, etc. Then under intersection tab, we have type of intersection, its quality, etc. And under flow tab, we enter how much traffic is there on the road, how many pedestrians and bicyclists use the road in peak hour, etc. And under vulnerable road user facilities and land use tab, we enter details of what is the land use, area type, are there any facilities for pedestrians and bicyclists, etc. And finally, under speed tab, we provide the information on speed limit and operating speed. As we enter the data in these tabs, the demonstrator keeps updating the star rating in real time. That is shown on the top of the screen for all the different road user groups. You can access iRAP coding manual, which explains the road attributes in detail, as we have heard in the previous presentation, by clicking on the help icon, which is again shown on the top of this page. Now, using this road image, we'll run the demonstrator to get star rating of the 4 different road user groups. Before I start, I want to mention that part of today's assignment is to be completed using the star rating demonstrator. In the assignment, you'll be provided with an image of a road segment similar to this one, for which you will have to get star ratings, and also you will have to suggest up to 5 safety treatments which will help to improve the star ratings. So now I have opened the demonstrator tool parallel to the image. While we make selections of attributes in demonstrator, there are few attributes which we need to mention, whether it is on the left side of the road or on the right side of the road. In the coding form, you will see the terms like driver side and passenger side. In India, we drive on left and driver sits on the right side of the vehicle. Hence, driver side means right hand side and passenger side means left hand side. So let's start with roadside attributes. Under this, we have roadside objects and presence of shoulder. In the image, we can see on right hand side, there is some concrete structure present, which is within 1 meter from the edge of the carriageway. And similarly, on passenger side, there are a few trees present, and again, it is within 1 meter from the edge of the carriageway. So I am filling these attributes in the demonstrator form. Roadside severity, driver side distance, 0 to 1 meter. The other options we have are 1 to 5 meter, 5 to 10 meter, and more than 10 meter. And the object, we have the list. Several types of safety barriers are listed: upward, downward slope, rigid, semi-rigid structures, trees, signposts, etc. So in our case, it is rigid structure, bridge, or building. And on passenger side, distance the same, and object is tree. Shoulder rumble strip not present. Paved shoulder on driver side and passenger side. As we can see in the image, there is no edge line marking present. Hence, we say paved shoulder is not present. So none on both the sides. The other options we have are narrow, medium, and wide. So now going to mid-block attributes. So we have all the major mid-block attributes listed here. The road segment is undivided and has centerline median with one lane per direction. Lane width is medium and it's straight. There is no curvature present. The road surface condition is adequate as there are no potholes. However, the delineation is poor. So coming to the demonstrator form, carriageway label is undivided. So we have options to do divided carriageways. And upgrade cost, I leave it to the default option as it doesn't affect star rating. The median type, so in the list we have safety barriers of different types, physical medians of different width, center line, etc. In this case, it is center line rumble strips not present. So number of lanes, 1. So here, when we code the number of lanes, we always code the number of lanes per direction. So here in this image, we can see 2 lanes, 1 in each direction. So in the direction of the survey, there is 1 lane. So we say the number of lanes as 1. Then we have lane width. It is medium. So we have options as narrow, medium, and wide. And iRAP coding manual explains in detail on how to visually assess the width category of a road lane. So here it is medium. So next we have curvature. There is no curvature. It is straight or gently curving. So we have options such as moderate, sharp, and very sharp. And coming to quality of curve, as we don't have a curvature, the quality is not applicable. If the road has curvature, the quality of curve will indicate the presence of road markings and signs to warn the drivers in advance. So our case, as there is no curve, we say it is not applicable. Then grade, as the terrain is flat, it comes in within 0 to 7.5%. Then road condition, this is in terms of presence of potholes or surface deformations, which may cause sudden changes in drive path. So in this case, there are no potholes or deformations. So road condition is good. Then skid resistance. If there are no loose particles present on the road and if the surface is not shiny, causing the vehicle to skid, we can code the skid resistance as adequate. Also, iRAP coding manual details out on how to categorize road condition and skid resistance into adequate, medium, and poor categories. Delineation, as we have already seen, it's poor as the edge line marking is absent. Street lighting is present. We can see a light pole in the image. Vehicle parking, we have 3 options. None, parking on one side, parking on 2 sides. In this case, you cannot see any parking, so none. Service road not present. Road works, if there are any construction activities going on the road, which is being assessed, we can code it here. So in this case, no road works, and side distance is adequate. If the driver can see pedestrians on the road well in advance, we say side distance is adequate. If there are obstructions, then we code it as poor. So next we have intersection attributes under intersection tab. So as we can see in the image, there is a 3-leg intersection with no channelization, and also there is no signage or marking present to warn about an intersection. So under intersection type, in demonstrator, there are different types of intersection listed: 3-leg and 4-leg intersections, with and without protected turn lane, with and without signal, and also there is merge lane, roundabout, etc. So in this case, it is 3-leg unsignalized with no protected turn lane, and there is no channelization present, and intersecting road volume. So here, as we see in the supporting data, it falls in 100 to 1000 vehicle range. Quality of intersection, as there is no signage or marking, we say it is poor. And next we have property access. So these are access points or driveways from adjoining property opening onto the road from where vehicle enter the road. So it can be a fuel station or a commercial building or a residential building. So here it is none. Next, going to flow attributes. So as we can see below the image, so all the flow attributes come from the supporting data. So here we can enter ADT, this 10,000 vehicles. Motorcyclist share falls in 11 to 20%. Pedestrian peak of flow across the road, we have 50, and again it falls in 26 to 50. Then we have peak of flow along the road on driver side and passenger side. It also falls under this range. And finally, bicycle peak of flow, we have 30 bicycles, and that falls in 26 to 50 range again. After flow, we have vulnerable road user facilities and land use. Under this, we fill land use, area type, and facilities for pedestrians, bicyclists, and motorcyclists. As we can see in the image, there are some houses across the road on the driver's side or right-hand side, and also on the left side between the trees, we can see a building. So it's either a shop or a bus stop waiting shed. So we say it is commercial. So the driver side, land use is residential, and passenger side, commercial. And area type, as there is no thick settlement, we say it is rural. And coming to pedestrian crossing facilities, so we have these options, signalized crossings and unsignalized crossings of different types, raised crossings. So in our case, it is no facility. So this is for the inspected road or the main road, which we are assessing. And here below that, we have quality of the intersection. So as there is no facility, quality is not applicable. And next we have pedestrian crossing facility for intersecting road or the side road. So on this road also, there is no facility for pedestrian to cross. So again, we say no facility. Then we have pedestrian fencing, it is not present. And after this, we have sidewalk on driver side. So that's on the right hand side. So here we can see the pavement is till the object. So we don't have space for pedestrian to walk outside the pavement. So we say on driver side, no facility. And on passenger side, even though there is no physical purpose-built facility, there is some space available for pedestrian to walk outside the carriageway. So we say it's an informal sidewalk. So we can select informal path 0 to 1 meter. So this is a snapshot from the types of sidewalks as per iRAP coding manual. So here we have sidewalk with physical barrier, sidewalk with non-physical separation. So these are the purpose-built sidewalks. Again, it is categorized into 3 based on its separation from the edge of the carriageway or the vehicle lane. It is 0 to 1 meter, 1 to 3 meter, and more than 3 meter, 3 categories. And after that, we have informal sidewalk, again categorized into 2, 0 to 1 meter away and more than 1 meter away. And if there is no facility, we say none. So coming back to the demonstrator, we next have facilities for motorized two-wheeler. So we don't have any facility, so we say none. And same for bicyclists, no facility. And finally, school zone warning and school zone crossing supervisor. So if there are schools present on the road segment being assessed, presence of associated warning signages, flashing beacons, or crossing supervisor can be filled here. In this case, as we don't have a school present, we say it is not applicable for both. And finally, we have speed attributes. So under speed, we have speed limit. So this is the posted speed limit on the road, and it comes from survey video. And as we don't have any signage visible in this image, we take it from the supporting data. So that is 60 km/h. Next, we have differential speed limit. As per iRAP coding manual, when the difference between speed limit of different vehicle type is more than 20 km/h, differential speed limit is present. Here, we have only one speed limit for all the vehicle types. So therefore, differential speed limit is not present. Then speed management or traffic calming. So if there is a speed calming measure present on the road segment, such as a speed hump, it is entered here. So in this case, there are no speed calming measures, so not present. And finally, operating speed or 85th percentile speed. And this comes from supporting data. So it is 65 km/h. So after all the attributes are entered, we can see the star rating and the star rating score for the different road user groups. So as we can see, all the road users, that is vehicle occupants, motorcyclists, pedestrians, and bicyclists, have achieved 2-star for the existing infrastructure or the baseline infrastructure. I want to mention in your assignment, you will need to note down this star rating score and star ratings for the image which is given to you in the assignment form. So now we know what is the baseline star rating for this road segment, and we can now think of providing some safety treatments in this location to improve the safety. So what safety treatment do you think will help to improve the star rating? So we have a question on Mentimeter with the same code. So here there are 10 countermeasure options given: delineation, paved shoulder, pedestrian crossing facility, sidewalk, intersection quality improvement, speed calming, shoulder rumble strip, etc. And you can select 5 safety treatments in the order of importance which you would like to implement for the situation. So we can have a minute for this. So we have around 25 entries so far. So the top entries are delineation, pedestrian crossing facility, sidewalk, speed calming, intersection quality improvement. As we are running out of time, so let me go back to the presentation. So before we go to the treatments, I want to show the chart view of star rating, which is available by clicking on the chart icon, which is shown below the star rating. The chart view shows crash type wise split up of star rating score or risk score. So this enables us to know which crash type is causing a higher risk. So here in the background, the colors and the numbers shown here are star rating score bands, and the inner bar for each road user group, it is the star rating score for the particular user. So here for vehicle occupants, we can see the inner bar is reaching till 15. So looking at the star rating, you can know it's around 16.41. And also the color coding inside the bar shows the split up of the star rating score in terms of different crash types. So for example, for pedestrian chart, we can see this blood red color, that is in the region we can see crossing through road is posing the highest risk. So this indicates what treatment can give the best results, or else by providing a crossing facility, we can improve the star rating or reduce the risk score of pedestrians. So similarly, for vehicle occupants and motorcyclists, we can see that the blue color, that is intersection crash, is causing the highest risk. So now let us try some low cost treatments and see how the star rating improves. As we saw in the chart that the pedestrian crossing risk is high, we can try some simple crossing facility. So first, let's start with zebra marking, which is simplest. So here, under vulnerable road user facilities, I'm changing the pedestrian crossing facility on Inspector Road to unsignalized marked crossing without a refuge. So that is a zebra marking, and as we are constructing is new, so we'll assure that it meets the standards to have adequate quality. So now we can see the star rating score for pedestrians has decreased from 85 to 72, even though the star rating is still 2-star. Now we can try some other facility, a better one. So let's say unsignalized raised marked crossing without a refuge. This is a tabletop crossing. So here the star rating score has further reduced to 61. In addition to that, we have also seen for vehicle occupants and motorcyclists, intersection was crossing the highest risk. So here we can provide some low-cost treatment to the intersections. Let's say we'll change the quality from a poor to adequate by providing some signages and marking to warn about the intersection. We can see the star rating score has further reduced. And also another easier option is to improve the delineation. So here delineation I'm changing from poor to adequate. And as we have already discussed, we marked no shoulders as the edge line marking was absent. So when we improve the delineation, we provide edge line marking also. So we can code shoulders as narrow. So we'll get a narrow shoulder of width 0 to 1 meter on both the sides. And finally, I'll also think of providing some traffic calming measures as we have presence of pedestrians and other vulnerable road users on this segment. So with this, we can see the star rating for vehicle occupants, pedestrians and bicyclists has improved from 2-star to 3-star. But still, the vehicle occupant, the motorcyclist is achieving 2-star. However, the star rating score has decreased from 19.3 to 14.6. So in a situation like this, it may not be possible to get minimum 3-star for all road users. So it may not be also cost effective to build another facility or a dedicated lane for motorcyclists. So I'll leave it as it is. Before I close, I want to mention a few things about today's assignment. As I mentioned earlier, part of today's assignment is to be completed using demonstrator. And in the assignment, you will be given an image which you will have to star rate similar to how it was done today. And there in the form provided, first note down the star rating and star rating score after you finish entering the baseline attributes. Then list up to 5 treatments that you would like to implement in the form as shown here. And thirdly, note down the revised star rating and star rating score after including the above treatments. Also, I would like to add another important thing about the assignment. So when you think of safety treatments, do not reduce the speed limit or operating speed. So we know that speed is very important factor in road safety and star rating. So let's say if someone reduces the speed to 30 km/h without doing any engineering treatment, he or she may easily achieve 5-star for all road user groups, otherwise which may not be possible. So here we want you to try and implement low cost and easy to implement safety treatments first. So like we have done, so you can go for low cost and easy to implement like delineation, zebra marking, etc. In some cases, for example, in roads passing through urban areas with the presence of pedestrians and other vulnerable road users, the speed limit may be dropped, but it has to be done in combination with appropriate engineering treatment such as a traffic calming. So that's all about the assignment, and I hope using star rating demonstrator is clear to all of you. Thanks, and I can have any questions if you have.
Yes, thank you, Jigesh. Very good presentation and demonstration. We have a few questions about how do you measure on the screen or on a photo, how do you measure the distance of a roadside severity?
So we have details of how we can assess visually the width of lane and distance of object from the image. So basically what we do is we relate it with the width of vehicles or the width of lanes. So if we know the approximate width of a car, so from that we can assess what would be the width of the lane, or from that again we can assess what is the distance to the nearest object.
Yes, and another question was...
Sorry, Ellie, if I can add to that answer. Simple answer is that if you really want to measure exact distance, you will have to use a system like network survey vehicle, which I have shown. And then there are some iRAP accredited systems. You can visit the iRAP website and get list of iRAP accredited system. They often have this facility within their software. But as for the demonstrator session, or if you are using the small action camera, which I have shown, what Alvin said is perfectly correct. You have to do some guess estimate. Thanks.
And the other question is, can we code only a few or select a few countermeasures to code to do the star rating?
Ali, so here in demonstrator, we can do as much as we need. So I was just showing it as 5, and also for the assignment, you'll be asked to fill up to 5 treatments. So if you have possibilities, you can do as much as countermeasures you can, provided it is feasible. Thank you.
Okay. So
sorry, I can again add something. So as I understand, your question was, if we have 50 plus road attributes to get star rating, and someone has got just 20 of them, no, you cannot do star rating with only few of the road attributes. You can't leave blank other road attributes. The model will not process data. So there is something called iRAP light star rating model in discussion. It is still in the discussion. I'm not sure when it's going to be there, but if the light star rating model is there published, then you can do star rating with limited data as well. Thank you.
Okay, thank you. So we had many questions during the session. We ran out of time. We will post your questions. We have posted today some of your questions from last session, and we'll post everything that we didn't answer today in the next couple of days. So today, in conclusion, we saw the background of data of what IndiaRAP is doing in the country, the fundamentals of the star rating and safer roads investment plan methodology, and how to use the demonstrator. As I said in the beginning of this session, we have more resources for you about this topic on Schoology. Each session will have pre-reading materials and an assignment. You need to click on these folders, topic 1, to see the assignment and the materials for the session, and topic 2 to see for the today's session. So to access the pre-reading material, you click on topic 2. You should have seen the pre-reading materials for this session already. And then once you click on this topic, you need to read or to click on all these materials to unblock your assignments. Otherwise, you won't be able to access your assignments. So, and then to access your assignment, you can see that it gets green, view the item there. And then you click on topic 2, assignment A. You have 2 assignments for this session. On topic 2, you have 5 questions. Here you see the instructions. Then you need to click start new attempt. And you have the chance to review your answers. You need to click, after you answer your questions, you need to click review your answers and submit. If you don't do that, you won't submit your assignment, and we won't see that. So once you submit, you will be able to see your grade on the right inside. So, and then once you complete the topic 2 assignment A, you unblock topic 2 assignment B. This is what Albin just explained to us. On this assignment, you will have this instruction, the image, and also very important, there is a Word document attached on the bottom of this page. This Word document has the instructions to this assignment and a form that you need to complete. Follow these instructions, code the image, this image that you see on the screen, using the demonstrator, and complete the form with your results on Vida. Once you have done that, click Submit an Assignment. And then on this icon here, you need to upload your Word document that you complete with your results. And then you upload the document and click Submit. So you see here, assignment submitted. Please just wait a couple of work days that we will give your grade. We'll assess your assignment and give you a grade. Once we give your grade, you see there on the side, on the right-hand side. And then if you don't pass this assignment, we will make comments there for you to improve your assignment or contribute to your knowledge. So thanks for all your questions and your participation. It has been amazing, very clever questions. And if we didn't answer a question today, we will post your questions on our welcome chat. Please have a look there on the next days. We have more information about everything we talked today. You see here, we talked about the Road Safety Toolkit, VIDA, and also the resources on our website. We also have the Bloomberg and the World Bank websites. Many people are asking, how can I join the Bloomberg or the BIGRS project? Please enter on their website and contact them directly. Our next session is on Tuesday, 9th of June, at the same time, 10:30 Mumbai time, and we will present Introduction to VIDA. So we already had a few questions about VIDA. We'll talk more about it next time. And again, please answer our feedback form once we end the session. There will be a pop-up screen with the form. Very important, your feedback for us to improve our webinars. And thanks everyone for attending our second session of the BIGRS and IndiaRAP webinar series. Thanks to our presenters and to our sponsors. Have a great end of the week and weekend, and we'll see you again on Tuesday. And we'll see you again on Schoology. Bye.
Thank you all. Bye-bye.